Hi guys, sorry I'm not here today, but you have a wonderful substitute with you today. The way we're going to work today's lesson is I'm going to be teaching you up here on this video. There'll be times where the substitute will pause this video so that you can get out your materials, take your notes, or complete the activity. Just ask for more time if you need it. These videos are also posted up on my YouTube channel, so if you need to re-watch them, go ahead and do that. You can also let anyone who is absent know that the videos are up there. Please work as quickly as you can during the breaks so that you can make sure to keep up with the video. First thing I am going to do is go over your homework from last night, so that would be this worksheet. You can take that out. If you need to pause the video here, you can do so. Okay, so we're just quickly to go over the answers. Number one asks you to explain the difference between a graph that is discrete and a graph that is continuous. Discrete is a collection of points that are not connected, kind of looking like this, whereas continuous is a graph with no breaks. This is just one example here. Number two asks you about linear versus nonlinear. Linear has a constant rate of change, or looks like a straight line, something like this. Nonlinear, there is no constant rate of change. Could be several different lines like this, or it could be a curve. In the problem that's in the bottom, it asks whether you to tell if each graph is discrete or continuous, and whether it's increasing, decreasing, both, or neither. Number one was done for you. Number two was continuous and both increasing and decreasing. Number three is continuous and decreasing. Sorry about that, we got cut off a little bit with problem set one. So number two is continuous and both increasing and decreasing. Number three is continuous and both and decreasing. Number four is discrete and both. Number five is continuous and both. Number six is continuous and increasing. Remember, increasing as you move from left to right, it's coming up, whereas decreasing as you're moving from left to right comes down. For the next set, you were asked to tell whether it's linear or nonlinear, and then describe the increasing, decreasing, neither or both. 8 was linear and increasing. 9 is nonlinear and both. 10 is nonlinear and both. On the last page, you were supposed to write a story that goes along with your graph. Go ahead and share that with your partner for about 2 minutes, and then get ready to take some notes. You can pause the video here. Okay, we're getting ready to start our notes here. I'd like you to take a minute, and I'd like you to do this warm-up. Sketch a graph that is a function that is nonlinear, both increasing and decreasing, and it has zeros at -3 and 2. So go ahead and pause the video, and everyone try the warm-up. Okay, everyone should have a different answer so you can share your work with each other. But basically, you want to start with your graph. Mark your zeros first at -3 and 2. Remember, zeros are where it crosses the x-axis. We have to be nonlinear. It has to be a function, and both increasing and decreasing. So my example just looks like that. Again, as long as yours meets those categories, it doesn't matter. Okay, we're going to move on to some notes. You want to copy this down as I work. You're going to do some examples with me, some on your own. But the first thing you want to copy down is the sentence. If we're given a function rule, we can create a function table. We have our x as our input, our y as our output. So here, this function rule of y equals x plus 3, and I've made a function table. Now, you can put anything into your input and then be able to find its paired up output. So something I want you to keep in mind, when you're doing that, you want to make sure to use a variety of values, both positive, negative, and probably even 0. You could use decimals, you could use fractions, but those might not be the easiest to work with at times, but you might not want to use those. But keep in mind, you can put anything you want in your input. For my example, I've decided to use -1, 0, 1, and then jump a little bit to 4. Once I've done that, I'm substituting each input into the rule to find the output. So my output would equal -1, my input, plus 3, which we know to be 2. Here I would have 0 plus 3, or my output would be 3. If I substituted 1 as my input, I would have an output of 4. All I'm doing is substituting my inputs in for x, solving it and finding my output. And finally, we would have 4 as the input, and we would get 7 as our output. I have one over here I'd like you to try. So write your function rule, y equals 4 plus x, and draw your function table. Go ahead and select whatever you want for your inputs and find the outputs. So pause the video here so that you can do that. Okay, so you can pick any input that you want. Say we did -3, 0, 1, and 5. You may match mine, your mix may be different. You could add mine to the bottom if you would like. So here we have y equals 4 plus -3, which would be 1. Y equals 4 plus 0, which is 4. Y equals 4 plus 1, or 5. And y equals 4 plus 5, which is 9. Now, what's the point of function tables? Well, if we have a pair of x and y, what do you think we make? Well, if we take an x and a y together, we have an ordered pair. And if we have an ordered pair, we can graph it. So to go from a function rule, we create our function table, and then we can plot our points to create our graph. Now, you can do 4 points, you could do 10 points, and make your graph as accurate as you want. You need to have, in this instance, I'd like you to have at least 4 inputs, and then 4 outputs, and then be able to plot 4 points. You could always do more than that. Okay, so from a function table, again, we can create a graph. Just take each ordered pair, plot them, and connect the dots. We're going to do 2 more examples of these before we go on. So go ahead and get ready for that. Okay, we have a couple more examples on the board here. In this first example, I'm going to walk through this one with you. This time we have a 2-step function. So again, you can pick anything you want. Do not overcomplicate it for yourself. So -1, 0, 1, and 3 is what I've decided. So now if I substitute 4 times -1, take away 3, that's going to give me my output. So we'd have -4 minus 3 would be -7. Take your time and show your work. For the second one, I would have 4 times 0, take away 3 equals my y. 4 times 0 is 0, minus 3 equals y, and I would get -3. 4 times 1 minus 3 equals y. That would be 4 minus 3, which is 1. Again, if you need to pause the video, just ask the substitute to pause the video so you can get your notes down. And for 3, we'd have 4 times 3, take away 3 equals y. 12 minus 3 is 9. Now, as I said earlier, each x and y pair makes an ordered pair. So you can write ordered pairs, -1, -7, 0, -3, 1, 1, and 3, 9. With those values, you can plot them on your graph. Excuse that it's not a perfect graph, but -1, -7, 0, -3, 1, 1, and 3, 9. If I could draw perfectly, you'd see that was a straight line. And because you could put any input you want, these go on forever in both directions. I'd like you to go ahead and try this next one on your own. So pause the video here and give it a try. Okay, so we're ready to go over this one. Again, any inputs that you want. I just picked some easy ones. As you substitute, -1 times 2 would be -2 plus 1, -1. 0 times 2 is 0 plus 1 is 1. 1 times 2, or 2 plus 1 would be 3. And and here we would get 5. You can make ordered pairs. And you can plot those. No matter what inputs you selected, you will come up with the same graph, because we should either include yours either if we extend it on or within the points that I have. So we have -1, -1, 0, 1, 1, 3, and 2, 5. Okay? Okay, we're going to do an activity for the rest of the period called Show Me the Money. So I'm going to have a substitute pass out both this worksheet and this worksheet. Let me give some instructions before you do that. You're looking to make some extra money after school and on the weekends with a part-time job around your neighborhood. You've put out flyers to your neighbors that you are charging $12 an hour to do some basic yard work such as raking leaves, weeding, shoveling snow, etc. Complete the table below, so you get to pick any inputs that you want and come up with the outputs. Write an equation to find your total salary in terms of hours worked. Most likely you use that equation as you solve the table, but now I want you to use the x and the y and an equal sign. How much money would you earn if you worked for 18 hours? You're going to use the equation to substitute and find an answer, and then explain that connection. Then I want you to graph your table on this paper. Make sure to draw your axes. Once everyone has their graph, you can do the back of the first worksheet. Because the back asks, you're not really going to do a gallery walk, but you are going to look at each other's graphs. I want you to list 2 things that all the graphs have in common. You can look at your neighbors to the right, to the left. 2 differences when you view the graphs. And is there a pattern? I want you to write at least a sentence or 2 on this. Okay? You are working in pairs, but everyone is completing their own pages. When you are finished, make sure that you can put these together and they get handed into the bin. Again, this side needs to have sentences. I do not want to just see one-word answers. On the front, I should see work, not just answers. Make sure your graph is labeled. You have your axes, you have units, you have titles. Okay? You have the rest of the period to work on this, and then hand that into your bin. Have a great day, and I will see you guys soon.